In this video, we're going to look at the basic principles behind the index laws. Now, the first index law says, assuming that the bases are the same, if you have a to the power of m times a to the power of n, when you combine those, because the base is the same and you can, because this is a multiplication, you need to add the powers together, so you get a to the power of m plus n. We've got a similar rule if it's a division. So if you've got a to the power of m divided by a to the power of n, which you can also rewrite as a fraction, so it might be seen as a to the m over a to the m. This time, instead of adding the powers together, assuming the base is the same, you can subtract the powers, so you get a to the power of m minus n. We have the case as well if we've got a bracket, such as a to the power of m all to the power of n. So how can we rewrite that? Well, if you have a bracket with the two powers, all you need to do is multiply the two powers together, such that you get a to the power of m times n. And if you have a multiplication in the bracket, such that you've got a times b, all to the power of n, all that this means is that you need to apply the power to both parts. So a to the power of n times b to the power of n. Now let's use those rules for a few simple problems. Our first problem, 1a, says 2 to the power of 3 times 2 to the power of 6. So for this one, we're going to use the top rule. Because it is a multiplication and the bases here are the same, we can add the powers together, such that we have 2 to the power of 3 plus 6, which when it combines gets us 2 to the power of 9. Using a little bit of algebra then, same idea with the rules. If we've got x to the power of 3 times x to the power of 8, because it's a multiplication, we can add the powers such that we have x to the power of 3 plus 8, or in other words, x to the power of 11. A similar idea with the next one, even if we have a negative power there, so we've got x to the power of minus 3 times x to the power of 8, still a multiplication, so we're still going to use the top rule. So we're still going to add the powers, so we're going to have minus 3 plus 8, which gets us x to the power of 5. Moving on to part B then, this time for these problems we've got a division, so we're going to use the second rule. Such that the first one, BI, says 3 to the power of 5 divided by 3 squared. So our base is the same, so that stays as a 3, and because it's division, we subtract the powers. So 5 minus 2, which gets us 3 to the power of 3, 3 cubed. Similar idea with the algebra then. If we've got y to the power of 7 divided by y cubed, because division, we subtract the powers, so we get y to the 7 minus 3, or in other words, y to the power of 4. For BIII, we've got y to the 7 divided by y to the minus 3. Well, we apply the same rule because it's division, so we have y to the 7 minus 3. Minus and minus become a plus, so we get really y to the 7 plus 3, which gets us y to the power of 10. Let's have a look at C then, which is going to use some of the last rules then. If we've got our brackets, we've got 5 cubed all squared, or all to the power of 2, so this is going to use the third rule. And the third rule says if you've got the brackets there, you can multiply the powers. So we've got 5 to the power of 3 times 2, which is the same as 5 to the power of 6. A little bit of algebra, same rule again. We've got our brackets, so we're going to use the third rule. We've got z squared all to the power of 4. So we've got z, and because of the brackets, we multiply the powers, so 2 times 4, which gets us z to the power of 8. And then the last case is going to use the fourth rule, because we have a 3 and then times a z to the minus 2 all cubed. So the fourth rule, we've got to break it into the two parts. So we've got 3 to the power of 3, and we've got z to the minus 2 to the power of 3. We can then simplify this. Well, the 3 to the power of 3, or 3 cubed, is 27. And then we have z to the minus 2 all to the power of 3. So again, for this case, we're now using the third rule on this part. So because we have the brackets, you can multiply the indices. So we get z to the minus 6. So our final answer for this one is 27, z to the minus 6. And that's a section of problems using the basic index laws.